we ask what will happen if we start changing our function by adding a quantity on the end. Well, this is going to be what we call a vertical shift of the graph. Basically, we could graph the function y equals 2 cosine of x plus pi over 3 and put our graph with a center at y equals 3 right here. Normally, our graph would just be, if this weren't here, y equals 2 cosine of x plus pi over 3 would have the center axis at 0, and we would go 2 above and 2 below that center axis. But what that 3 is going to do to it is it's going to shift everything up. So I'll tell you what I do. On this kind of function, if I have to shift my graph, then what I'm going to do is I'm going to go along my y-axis right here and just start labeling here until I get the graph that I want. And so let's see, what have I got right here? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 markings right here. I'm going to actually treat each of these as 1. So here's 1, here's 2, here's 3, here's 4, here's 5. Okay. My new center axis, and this is actually kind of weird. I do this first. I say, well, I have a center axis that's going to be located at the line y equals 3. Why? Because, well, any place where 2 cosine x plus pi over 3 is equal to 0, y equals 3, that's where that occurs. So I just draw a nice dashed line in here. And this is now going to become like my new x-axis. Right? I'm still going to mark everything down here along my x-axis as I normally would, and here's my y-axis. But what does that mean to me? Well, our amplitude is equal to positive 2. If the amplitude is 2, then it says take your center axis, and to get the highest point, go up 2. So our upper value will be here at 3 plus 2, which is 5. And our lower value, if we take 3 and we go down 2, it will be at positive 1. Now I'm just drawing some dashed lines here to help guide the shape of my graph, but that's it. That's the only reason for having these points right here. So now what else can I say? Well, our period. Our period in this case appears to be simply 2 pi, and that's because b is equal to 1. But we do have a phase shift. Our phase shift is found by setting the quantity in the parentheses equal to 0. So if x plus pi over 3 is equal to 0, then our phase shift is x equals negative pi over 3. So our phase shift left negative pi over 3. All right, so far so good. Well, what else can be said? Well, okay, if our period is 2 pi, our phase shift is pi over 3, we also need how far apart the key points are spaced. Well, key points are found in these graphs by taking 1/4 times the period. And 1/4 of 2 pi is pi over 2. So each of our key points are pi over 2 apart. So this is where I start making a table. For my x values, I always start at my phase shift of negative pi over 3. But then what I'm going to have to do is I'm going to have to add this increment of pi over 2 to get all my other key points. So I'm going to have to start adding by pi over 2. All right, well that means we're going to have to get a common denominator. Pi over 2 and pi over 3. If we wanted to add negative pi over 3 plus pi over 2, we'd have to get a common denominator. It looks like that common denominator is 6. So I've got negative 2 pi over 6 right here added to 3 pi over 6. And that just gives us 1 pi over 6. but that gives me an idea. If I'm actually graphing my function right here, one way of getting some of these key points right here is just to go by adding, starting this is negative 2 pi over 6, like we just said, it'd start adding increments of 3 pi over 6, which was pi over 2. So we got negative 2 pi over 6. We had positive pi over 6. We're going to add 3 pi over 6 again, and that's going to give us 4 pi over 6. Add 3 pi over 6 again, that's going to give us 7 pi over 6. Add 3 pi over 6 again, that's going to give us 10 pi over 6. Now, none of these are reduced, so I'm going to reduce them in order to use them. In the reduced form, 4 pi over 6 is 2 pi over 3. I'm going to add 7 pi over 6. Again, that's not an increment. That is anything consequentially. 10 pi over 6, though, that reduces to 5 pi over 3. So, if I'm looking for key points, this is where they're going to be. What's going to happen at each of these key points? Well, normally, again, because it's a cosine, normally we would say 1, 0, negative 1, 0, and 1. But, in fact, our graph is going to start along the center axis this time and go as high as 5 or as low as 1. So, instead of starting at 1, we're going to start at 5 this time. We're going to go down to our center axis at 3. We're going to go down to our lower amplitude value at positive 1. That's 2 below the center axis. Then we go back to the center axis, and we go back up to 5. Right? Now, if you don't see it, let me mark off my axes right here. Here's negative pi over 3. Each of these blocks right here are by pi over 6. So here's pi over 6. Go 1, 2, 3 more over. We're at 2 pi over 3 here. Go to 7 pi over 6. And one more cycle, we're ending at 5 pi over 3. And then I go for my y values, which start at 5 here, at negative pi over 3. Go down to 0 at pi over 6. Go down to 1 at 2 pi over 3. Back to 3 at 7 pi over 6. And then finally up to 5 at 5 pi over 3. So here's one cycle of this cosine function passing through each of these key points, but shifted upward from 0. Now, if it will help you, if all of this shifting up here, up and down, doesn't help you out, one way of thinking about this is that, well, if this were just a normal non-vertically shifted graph of cosine, we would have seen something that looked more like this, a graph that passed through each of these key points here at negative pi over 3, pi over 6, 2 pi over 3, 7 pi over 6, and then back up at 5 pi over 3 right here. And all of these points are shifted upward by 3. So we see that what's happened right here is that our graph is vertically shifted upward. So that's what we mean. So we graph just like we were graphing 2 cosine of x plus pi over 3, and then just add that 3 at the end. So there's another strategy for you to do this. All right, more videos to come.